for joining. Enjoy the webinar. Over to you, Howard.
Great, Debs. Thank you very much. All right, so let's start off. Let's start the process going. Okay, great. So you may have seen quite a few questions on the LinkedIn post, and I'm busy working through a AI governance training program, and the AI governance training program is geared towards data governance people that have recognized that we need to start to encourage or engage on this being able to understand AI, so and to work with it. So it's about trying to give some background as to what these different terms are, and these terms can get quite hairy. And when you look at some of the things, it's like, oh, I have no idea what you're talking about, and that somehow, and it does that to us. We then start getting a little bit concerned about asking the questions we should need to ask, and the checks that we should need to put in place, because we don't really understand. So this is not for those people that have been into AI governance and AI for a long time. It's more about trying to help those of us that are getting into it for the first time, and trying to just show you how the basics of this AI is working. And now we're starting with machine learning, and how do you make sense of it? How do you make sense of what the people are doing? I think that's really important. Sorry, I'm just missing my. Okay, great. So I'm using as a guide for my training, I'm using the Informs analytics body of knowledge, and they are the people that deliver that CAP certification, Certified Analytics Professional, and there's 3 different levels. And so I'm just using this book as a backdrop, or as a fundamental, so one can work through that book. So if you're looking for some of the content, you can find it in the ABOK. I'm not sure how many people are registered with Informs. I found it by chance some time back. I was looking for a certification on analytics, and I found that, of course, the DMBOK is nowhere when it comes to analytics in terms of its certification, but there are systems out there. Hopefully with DMBOK version 3, we will correct that, and we will bring in more appropriate content to handle analytics, advanced analytics, and AI. Okay, and especially the governance thereof. That's probably the hardest thing. All right, so if you are interested, there's a crossword puzzle to make sure that you understand some of the concepts that we've been presenting. And there's a QR code to be able to do it. And we'd really love to see people interacting and engaging with it. All right, so let's start in the beginning. Again, I apologize for those of you that are well versed in this thing. And so what is machine learning? Here is machine learning sitting over here. And machine learning is a subset of advanced of artificial intelligence. So it's a branch, and within machine learning, we get neural networks that help us with the machine learning. And within that, there's deep learning. So there's this specialization that keeps on growing down the bottom here. So the 3 types of insights that we are looking for is the descriptive analytics. We've all heard that: descriptive, predictive, and prescriptive. So what are the differences between that? Descriptive talks about what's happened in the past. And a lot of times that's certainly what the DMBOK and the Robert Abate triangle does. It says BI is looking back in the past and it answers what has happened. But the machines need to learn as well as an understanding of what's happened. And then using that understanding, they can categorize or predict or understand potential behavior. And then the predictive is forecasting what will happen in the future. And there's different types of forecasting. A continuous number, for example, weight. What's your weight? What weight are you? And that could be based on your height. A lot of the times it is, but it could be based on other features as well. So we are there to forecast a continuous amount, a continuous value, weight, weather, temperature, claims amount, all those types of things. It's a level of forecasting. It's different to predicting an outcome, yes or no, this claim is fraudulent or not. We've got prescriptive is recommending actions to achieve the desired outcome. So if we see that, basically what can we do to improve where the prediction is telling us? So if the prediction is telling us that we are going to miss our budget by 100,000, what can we do to achieve that? And it was really interesting listening to Dale talking about his experience in the military in the Gulf, and his job was to forecast the demand or the supplies that were needed, and it was dependent on all sorts of things. So really nice to listen to that and listen to real life stories. Okay. So machine learning requires human judgment and oversight. This is the important thing. We need to be looking at what's going on, what decisions are being made by the data scientists along the entire journey, and that's really what I'm trying to bring about here is this understanding. Now, it's quite different to that of software development. Software development, traditional approach, we would go to the business, they would define the rules, and we'd implement them in software, and we can see the rules, which is fantastic. And we talk about putting these rules in business glossaries. Now, when it comes to machine learning, we don't see the rules, we discover the rules. The rules are discovered. Okay, so there's this sort of situation where on one side it's black and white, and on the other side it's building and it's growing and it's developing, and we're not always too sure what the rules are. And then what happens is we make a decision, and then we have to say, well, tell us why you made that decision, and that's important. Almost what we refer to as explainability. So the machine makes a decision, makes a prediction, and then we need to say, well, please tell us why you made that. What was the root cause, or what were the set of causes that helped that come about? Okay. All right, so here is just what I'm trying to do all the time is keep on relating it back to insurance and relate it back to healthcare. Okay, so try to give you some business examples. Okay, so let's have a look at this high-level flow. We could have claims data, policyholder, insured asset performance data, like your car or your house. The house is an insured asset. Is the value increasing? Is the value decreasing? Geospatial data, where is your house? Where is your car at this point in time? What is the weather like within your area? And geopolitical data. So there's all the data that can be put into the data lake or into a data warehouse. Depends on, for example, claim data and insured asset performance data. You may have that already within your existing system, policyholder, and then we could be getting geospatial data, weather forecast, geopolitical data from the outside into the lake. And all of this needs to come into this analytical data warehouse so the models can run on the structured data. It doesn't always have to be structured data. There are things that we can use LLMs to assess the language or the unstructured data, or NLPs as well, or images. But a lot of the times the models are working on structured data. They build the structured data, and then we can make use of these models from the different applications, an insurance portal, communication channel, CRM, claim management app, the underwriting system, accounting software. So they would like to have this model available, and at any point in time they'd like to say, okay, well, here's a claim, here's details about the claim. What can you tell me about that claim? What can you predict? And if it's going to be like this, what can we do to adjust it, or if the amount is too high? And so that's the process, and that's what we want available to us at all times. Okay, so if we look at the insurance domain, it's processing the claims processing automation. So can we reduce the amount of time that we spend processing these claims? For example, if we have to go and read all of the theft, the police record or the medical records, this takes time. And if people, and you may have 20 people sitting there, but you could have a machine that can absorb this content a whole lot faster. So it makes a whole lot of sense. Automating the claim, detecting fraud, preventing the fraud, healthcare, diagnosis, disease prediction, patient segmentation in terms of risk, and disease prediction and resource allocation. And I know that Paul's on the line. And Paul, I believe you've been doing quite a bit of this resource allocation. Is that correct, Paul? I heard you doing quite a bit of analysis or building a data model to keep the information about the resources that are working in a hospital, even things like the operating theatre and the machines. Well, is that correct?
Yes.
Okay.
It's on the roadmap. I haven't quite sunk my teeth into that, but it started with materials management and stock management. So yeah.
Okay.
So it's
okay.
Interesting. Thanks for this.
Right.
Brilliant.
So operations research, and Dale was even talking about that as a case of how do we allocate resources according to the current demand, and how do we improve the throughput? And that could be anything from clinics that are set up like, and then how many doctors should we have to meet the patient demand? How long are the patients waiting? All of these types of things, which is part of operational research. That's what we're trying to solve here. We're trying to improve the life and the efficiency of our customers and the service of our customers. Yes, we want to reduce the fraud, but I think that the one that really helps is where the humans are benefiting from us doing the job faster and smarter. That's really what we want to do. And then if we can save money, that would be fantastic. It also be great. So the three different paradigms that we have in machine learning. Let's go through those quickly. So we have supervised, which is learning from examples. So the models have labeled data where the outcomes are known. So going back to an insurance claim, they can have a claim with all of the features on it, and then it would be marked as this is fraudulent or legitimate. So there's the example. And then we could teach this machine the patterns on that data. And when we get a new claim, it can predict the outcome, okay, with clear success metrics. Okay, so that's what we're trying to understand is we've labeled a whole lot of data, we've given that training. Really important that training data needs to be clean. You can't train the supervised model on dirty data because it's then going to pick up a whole lot of noise and make some bad recommendations or predictions. Then we've got unsupervised. I think somebody's hand's up. Yes, is there someone with a hand up or not? I can't really see. Paul, would you help me if someone puts their hand up, or Debbie, would you just
Cool, will do.
stop, interrupt?
Cool,
Okay.
man.
Unsupervised is we're looking for patterns. Now the big one that I've seen used over and over again is this concept of customer segmentation and risk groupings and things like that. And unfortunately, that customer segmentation is where we can start picking up a lot of discrimination. So it just goes and has a look at the data. It talks about natural groupings, but because our data can have inherent biases, we could be entrenching those biases and saying, well, all the people that have been that have submitted false claims come from this area. Simple, very simple solution. Or they're this age, or they're this gender, or whatever it is, and then we get ourselves into a whole lot of trouble. Now, it may be right for that point in time. And what I've also discovered from a governance point of view is if our data is biased, there are techniques of going back to that data and trying to remove the biases so that we can train on the data that we have. So that's also an option from a governance point of view, is to say, yes, our data is biased. If we just look at South Africa, we've got some really strong biases in our data because of our history. So what can we do to undo those biases? Yes, William.
You know, this is such an interesting angle that you just opened up, because this is a industry, so to speak, for psychological people to step into the data world and start to analyze the psychology of bias amongst that data. That's never existed in the data field before. So this is creating a new piece of work, right?
Yeah, yeah. I think you bring a very important point in terms of being able to see. It's interesting because, you know, let's say we had the supervised learning, and we've had I can just, you know, you can just think of some of the problems. We label data as being fraudulent, and then we discuss that we discover that they've been marked as fraudulent because the people were black or whatever it may be, and they've been, these biases have come through, and then you discover them, and then it's a case of, okay, what should I do? And maybe I just say it was marked fraudulent, but it's legitimate. What do I do with those people? You know, how do I respond to that, William? So there's lots of challenges around this thing of correcting biases that were in our data and decisions that we made. We made some bad decisions. So I'd love to wonder how are we dealing with some of those things? How do we rectify the problems that we did in the past?
So you've got hands up from Kim and from
yes,
Dale.
Adam. Yes, Adam.
Howard, that's actually a core area that I deal with is the ethics and and the biases in training data. Right. And what do you do? How do you account for it? How do you compensate for it while you are working to correct it?
Right.
And there's a lot of different techniques for doing that. If we take a look at the first release, basically, of any new version of an AI system, it's a failure. It's got bias, every kind of bias you can think of. Grok had it, Gemini had it, ad nauseum. So how they release them like that is beyond me. How that is, there isn't some simple testing done before that, I don't know. But
yeah, and this is you bring a great point, and Dale was actually telling us the work that he's doing. He's doing his PhD on measuring the quality of LLMs, Adam. So Dale may be able to answer some of that.
Dale, I would love to get when
he's actually got an ensemble on things like echo chambers and hallucination rates and things like that. So I don't know if you remember in the previous thing, I actually showed the metrics that he uses and then the ensemble that he brings together to be able to detect it. And he was talking about going through that process. Dale, I know you've got a question up, but could you just explain a little bit to Adam in terms of what you're doing?
Well, I was going to kind of elaborate basically what you just asked me to do. So in my research, I found that I have 9 different categories of bias associated with large language models. And the propagation and amplification of those biases come at different points. So that's why I have these metrics. But the question of trying to eliminate the bias, misinformation, or error is kind of a double-edged sword, because there's a cost benefit. How much time and effort do you want to try to exert to try to clean that? And you're never going to get it 100% bias-free, misinformation-free, or error-free.
Right.
So what I did is I'm applying Six Sigma methodology where you have control limits. And so if Adam is producing rubber ducks And Howard's in the medical technology field, your degree of acceptance of that bias and misinformation and error is going to vary because of the impact on your business. So through using that methodology, you can set some control limits and you monitor how the model is performing in these different metrics. And you get the end result is you get a bias propagation index. And from that, you can determine, is it outside those control limits and what do you need to do? It'll kind of zero you in on what you need to do to try to bring it back in within those control limits.
Right.
But you can monitor it on an ongoing basis to make sure that the model is performing within your accepted parameters. And those parameters are set not only to the needs of the organization in terms of quality and accuracy, but from a cost standpoint to maintain that. And so it kind of gives you that dimension of it.
So two questions based on that, Dale. One, do you see any difference between the public scraped LLMs and LLMs that are created with synthetic data? Have you done that comparison? Any comparison like that?
I'm sorry, I hit the wrong mic button. So yes, I see some variations. And if you're developing your own large language model for your organization where you have control over what's being data is being fed to it, you get 1 degree. But if you're using the larger platforms like ChatGPT, Anthropic's, Claude, Llama, Genesis, you name it, you can get an API and link those to and what a lot of people are doing now, they're using Agentic AI and they're linking to these systems. So now you're accepting their level of bias, misinformation, error, tolerances. But within those, I tested 4 of these different platforms and I found a measurable difference between each of these platforms in terms of the degree of performance. So, and go ahead.
That was actually going to be my follow-up question was, can your practices be applied to the different models that are out there? And can it be applied easily?
Yeah.
Could you do an agentic AI workflow to have it evaluate?
Sorry guys. Sorry, Adam. We probably going to we can go down this rabbit hole. I think I will actually organize a session with Dale and then we'll have a more detailed one. At this stage, I'm trying to stay at the basics. We've gone quite far down the.
Okay.
But Adam, thank you.
I'm excited, Dale. I'm excited to see and hear
Fantastic.
about this.
Let's make sure that Debbie organizes a talk, probably after Adam's present research paper delivery. So Dale's got to get quite a few papers out shortly.
Research paper, not mine.
Okay. Yeah. Okay. So a lot of some of the examples that I've been using relate to claims data and tabular structured data, not so much the LLM. So that could be fraudulent claims, and we could have demographic information and location information that leads to biases. And then how do we correct that? How do we get rid of those areas that bring about discrimination? So we have to work on that. Okay, and then reinforcement is another approach where the agent learns optimal strategies by taking actions and receiving rewards or penalties based on it. So it learns from its consequences, makes a decision, and then gets a response back to say, that was wrong, and you've now had a negative reward. So here we can talk about dynamic pricing optimization. So How do we price based on time of day or, state of the traffic or whatever it is? And we've just been hearing about Uber that does pricing or dynamic pricing based on the state of your battery. So if your battery is low, then the price of the ride is going to be higher because now you have to make a decision a whole lot faster. Chatbot conversations, different areas like that, different strategies, how to engage with the user. So a lot of the times the agentic AI and chatbots have a conversation flow. If I'm taking in a claim, I need to get this data and I'll have a conversation flow. But and sometimes it gets too static, and we need to be able to adjust that and get a better set of answers out of that situation. So some really interesting optimization and reward mechanisms. And if you're rewarding on the wrong thing, then I think you can create some problems that your model's producing. Okay, so the data requirements, we can have label examples for supervised. We want raw data only for unsupervised. And then for reinforcement, we're talking about that feedback signals. So we make a decision and we get feedback. For example, we say that you've got a fraudulent claim, and then we'd look for some feedback from the customer in terms of, well, was it fraudulent, or what did they say something wrong, or whatever it is. So we need to get the answer back so we can give a reward or a penalty. Okay. The primary goal is to predict outcomes, predict where you're going to be and what your behavior are and what your needs are. To find patterns in the data, that's lots of insights. These are the people that, this is what an anonymous claim looks like. I shouldn't say these are the people that do fraudulent claims. This is what an anonymous claim looks like. It's got this structure. And always the nice thing about it, there are multiple features, 20, 30, 40 features that can help you with detecting a fraudulent claim. And that's no easy thing because you've got to work out what are the right features. Yes, William.
So one of the key aspects of decision making is the principle of conflict of interest, which we handle around people. We understand who they're connected to and whether or not you can be in this position because you're going to be making decisions about X, Y, Z. Do we have to have a look at this area of AI and understand who's coding what and all the rest of it to understand conflict of interest around those things? It's probably never been thought of, but
yeah,
it
is interesting, William. It is interesting in terms of some of the ethical consequences. And so, for example, if you are possibly rejecting student loans for, the low income families, they really battle to get out of it. So your model is the impact of you doing that unethical behavior because of where they're located is a lot bigger than rejecting someone who's got lots of money. And I remember doing that when I went to university. We got a loan so we could invest it and make more money, not because we needed it, but because we found a way of making money on the sidelines. Okay, so I do think we need to understand who this person is and the impact of our decisions, but conflict of interest in terms of, does it conflict the organization or the individual? Is that what you're referring to? Is this person related to us, our organization? Are they making us more money or?
Yeah, it was a different angle. So there's obviously the people who are having a look at the model and that sort of thing. But then it's the actual AI decision-making learning process itself.
Yeah.
If it has an incentivized, instantly incentivized, because it happens to be, for example, in a particular department, it has access to more of that department's information and tends to favor that department versus another department. It is beginning to build a relationship matrix, which amongst people would be quite obvious, but in the digital world is not going to be obvious at all, right?
Right. I mean, and it's interesting, this Uber scenario where they discovered that if your battery was low, we could charge you more. Now, what is that? What behavior is that we're introducing? So when you're in trouble, then that's when we can really push the money. So what sort of behavior is that we're introducing? But okay, let's not go too far on that.
My only question on that one is, was that a decision made by a human being, or was that something picked up by AI and implemented by AI?
I'm not sure. I'm not sure. I find this dynamic pricing to have all sorts of permutations, good and bad.
Yes.
We've always known about dynamic pricing in terms of heavy traffic load, and it means the person's got to take longer to get there and things like that. That we sort of understand, but now it's gone a level further.
Yes.
And the rights and wrongs, but let's keep going. Okay. All right. So let's give you simple examples of supervised learning. We have input raw data. We have a specialized training data set, and I can't emphasize the importance of getting that training data set right. And this is where the data governance people really need to understand what it is. What about these features and sets of features do we need to include in the quality around those features? Now, a lot of times what you would start off with is, let's take the insurance claim processing. We could have all sorts of information about the individuals, the people, the claims, the duration, everything that happened. So we could, and we could even be talking about the brokers that submitted the claims. And so we could, just the number of features gets really big. And we now have to reduce those features to as small as possible to improve the speed at which we predict and the amount of training that we need to understand. And I'm going to show you some of these training issues that come about. So the first thing we start doing is we start off with this massive data set with lots of features. We now need to bring it down to a set of appropriate set of features so that we're getting the desired output at the learning level. Okay, and once we've got this, then what happens is that we've got this model, we then do some of the processing, or the application calls it, and we have the prediction, and it predicts certain outputs. Okay, so that's typically what supervised learning is, and please, it's so important, the different techniques in terms of regression, which is predicting numeric values, your weight, and then compared to classification, which is predicting categories. So you've got weight, claim amount, weather, whatever it is, patient recovery time, and then you've got categories of fraudulent, non-fraudulent, disease, healthy, and there's a different set of techniques that you'll use for each one of these business outcomes. And once again, we need to understand what is the business problem or the business framing, and then what have we used the appropriate technique. But what I have been discovering lately is that getting our training data sets is probably more important than having the exact correct model. It's getting that right training data sets available to us. Okay. All right. Then we go on to unsupervised learning. Sorry. I forgot about this one. And really, linear regression, you're predicting a continuous number, price, temperature, age, relationship between it, and it appears to be a straight line. Hence the linear regression. The logistic regression is categorical outcomes. Okay. Incident types or fraudulent transactions or whatever it is. And there we have a simple example, predicting a house price based on its square footage. Okay, so if it's big, then it costs more. It tends to ignore the location, but there's a simple, for within the same location, that would be a grouping. This would be the square footage in the same suburb, as an example. So the size increases, the price generally increases in a straight line fashion. Predicting whether an email is spam or not spam. It's based on the words that it contains. So it's a different approach that we're trying to work through. Okay, Customer churn, that's another example of, getting customer lifetime value, and then what is the probability that this customer is going to leave us when it approaches that lifetime value. Then you've got unsupervised learning, where we really not bringing the SMEs in at all, right? So we're just saying, here is all the data. Now show me the patterns that you found. And there's a k-means clustering algorithm that groups unlabeled data into distinct clusters based on similarity. Okay. And we will need to assess these different clusters and these different groupings, because we'll probably behave differently depending on those clusters. Okay. And that's when we start causing the problem. So it works with unlabeled data. It discovers hidden patterns and structured with predefined outcomes. And what I found in my experience with the insurance claim is, what I've done is typically started with the unsupervised learning, looked at some of the patterns, and then gone back to start labeling. So it's almost this maturity has worked off as, this is a really nice way to start understanding your data by building these clusters and then seeing where some of your challenges are. Okay. And there's that centroid which determines the middle of that group. What is the middle of the group? Okay. Common tasks, clustering, grouping similar points, density estimations, finding data distributions, and we talk about that of the mean and the segment and the sigma, or the deviation, and then dimensionality reduction. So simplifying complex data. I think you'll be really surprised at how important it is to get that simplification. But if you oversimplify it, then you lead to making decisions on the wrong basis. Okay, so insurance uses for customer segmentation for targeted products, things like identity theft. Okay, is this product good for someone? Would someone really target a person to steal their identity and then register on all the websites and use their credit cards or whatever that may be? Okay, fraud pattern detection without labeled cases. That's what I've done. And then claims categorization and routing. Okay, so if it's a high-risk claim, then we've got to go to specialized people to assess high-risk claims, because the amount of high is high and we can be making some terrible decisions. So we've got to work through some of that as well. Okay, so here's a really nice example or visualization of reinforced learning. Okay, so we've got an environment that's got the data in it, and we have an agent, and the agent is asked to make a decision. That's the learner or decision making that takes actions. So depending on the state of your claim or the state of the environment, it makes a decision, takes an asset, takes an action, and says, okay, this is a fraudulent claim. It detects this scenario as the patterns evolve. Okay, and then when we get to the end and we tell the person or the SME to say that it was fraudulent, then the SME would give us a reward, in terms of saying, well, you detected it well. And what I found, I've used this one to be able to say, okay, starting off with my model, it's unsupervised, and then it's detecting fraudulent claims. And then using a reinforced learning in the background and allowing them to oversee what that unsupervised or supervised claim approach is using. Okay. And then each time we get customer feedback, we would then go back to the agent and either reward the agent or not. And the agent can be constantly monitoring some of the output. So there's not only one approach and only one model. You can be using multiple models at the same time. So just some examples: chatbot optimization, route claims dependent on customer feedback. Route them, learning to route efficiently. To say, they would say, you denied my claim, or you sent it for further processing. It took another 3 weeks. That meant I didn't have money to pay for the funeral. and I'm probably not very impressed with you at that point in time. Therapy recommendations based on patient outcomes, resource allocation, optimizing staff scheduling in response to demand patterns. Well, this is what we're seeing in the health area, especially when you have limited resources. I'm assuming you have materials, or I'm not sure if you've gone to operating theaters, machines. I've even seen machines that are moved around between hospitals depending on the demand. Okay, so now who makes that decision about where these machines go? And then fraud detection. So key advantage, unlike supervised learning, reinforced learning doesn't require labeled training data. That takes time. Okay. It learns optimal behavior through exploration and experience. Okay. So this is part of the thing is where I actually like to have it operating in the background and not having any problems. And then I'm feeding it rewards based on how that claim finally happened, how what it turned out to be. Okay, so I'd like to keep this reinforced learning in the background until it's getting these actions more appropriate. Okay. Yes, William.
How is AI dealing with human beings having, I'm trying to find the best word. It would be a case of, today I'm feeling this way, tomorrow I'm feeling that way. I will give you different answers because I'm coming from two different emotional states.
Right.
How does it balance that complexity amongst human beings? Or do people have to now?
It certainly does, it does and it should, but there is something called repeatability and reliability that you can measure the models on, William. So you want to try to get a consistent outcome, right? And when you start detecting inconsistencies, that's when you need to check on this model because it's not always working appropriately. So it is possible that it's having a different outcome based on similar type of claims, and that's really what you have to check out, and you have to keep monitoring that in that situation. Now, I suppose when you talk about an LLM, there's that concept of toxicity. Okay, so that toxicity can be increasing until it gets to breaking point where the responses are really bad. And so there's this concept of online monitoring and offline monitoring, where you're constantly looking at the responses that these models are making and trying to pick up discrepancies or inconsistencies. Does that help, William?
It does. You know, where my brain was going is, I think in order to stabilize the interaction with the human being better, you might want to put a call center group of people between them and the AI, and that call center is there to actually just harmonize people's feelings, etc., to the point whereby when they actually start to have the conversation, they're smooth, consistent, and are likely to give better quality to the AI to work with.
Yeah. Look, at the moment, I suppose the idea is to try to get the chatbot or the model to handle the big load, and when there are challenges, to quickly detect that there's a challenge and then change the person or the element responding. So go from a machine learning model to a person to actually deal with it. And there may be emotional readings on the way in which the people are responding to the chatbot. When that emotional reading or the sentiment or the tone is changing, then we need to escalate that to an individual to pick it up. Now, maybe it's the wrong way around, but I think what you're trying to do is reduce the amount of time it's taking for people to make a decision. If we can make the decision faster, we're going to get that person's claim processed faster, and for a person to do it will take longer. So I've seen it mainly work the first way, where it's trying to get it there until the person gets frustrated and then escalate. Maybe that's the wrong approach, but I suppose it depends on the business. But what we're trying to do is, can we automate as many of these queries as possible so we don't keep on growing the call center and then getting people to sit and wait on the call center?
No, I hear you. I'm just thinking about how we get better quality data, because the problem is that our data quality is going to be contaminated by emotions rather than in fact, people will respond differently, etc., etc., etc. Right?
Yeah. Look, I think it's about being sensitive, and then when it gets to a certain stage, then you need to go through. So it's about monitoring that interaction, and recognizing that we are picking up we're picking up emotional challenges, but it's
Okay.
Okay. So the typical flow is understanding the objectives of the business problem, then collecting the data that deal with the business problem. And so many times, just today, someone came to me and said, it's really interesting, Howard, what do I do here? The AI executive came along and he said he wants all the data of all the applications in the data lake. I said, wow, that's amazing. So he wasn't interested in talking about business problems. He wanted all the data, and then he was going to go and talk to the business. And then he was going to design some models. So again, an interesting approach. I thought it was quite, weird that they would tackle that. To me, it's about business problem first, then go and find the right data, not give me all the data and then I'll find the problem. Then it's feature engineering to get the right set of input variables. Once you've got the features right and you understand the relationships between the features, and I'm going to talk about that, then you go into the model training. Then we evaluate the performance of the model, and then we go into deployment, and then we continually model and monitor the performance. So again, deployment is not like a BI report. It's basically you go in there and you probably have to monitor more. Is there drift in the data? Is the model reliable in its recommendations? Are we having too many false positives, false negatives, whatever it is? We need to continually monitor it, and that's where your SMEs and your stewards are taking place, and they're monitoring the results. And I think we did talk about it the other day of banks using the person to be able to check whether this was a fraudulent transaction or not. So if they detect that maybe this credit card transaction was fraudulent, they send an SMS to the bank, to the person, and say, please tell us whether that transaction was fraudulent. So interesting that they're using us to now train their models in that situation. Lots of challenges around there. Now, key success factor, data preparation, 60% of the time. Okay, that's what's happening now. You constantly hear the situation where the data analysts or the data scientists are spending 60% of the time preparing the data. So it's this business problem definition, data collection, there's 60% of the time. Then the modeling is taking 25% of the time, and the deployment's taking 15% of the time. So data prep is our biggest challenge. And really, from a data governance point of view, if you can work together with these people to give them the right data at the right time, get it into the right level of cleanliness, define the right quality dimensions, you can be helping them tremendously. You can be doing a lot of that 60%, taking it off there. And they're not wasting time with that, and they're getting to the modeling a lot quicker. And of course, our data quality assessment or profiling of the data can help them with the feature engineering as well. So don't think it just stops at getting the data. If a feature is a critical data element, we as data governance people know how to work with critical data elements. We need to have a fit for purpose set of features that go into that model. So helpful for you to know what a feature is and what you can do to control those features and control the quality of those features. Okay, so here's just some examples of data acquisition. Of course, we've all seen this messy data. It's always there, and we want to get it into the clean data. Okay, I think we all are aware of that. Wherever possible, how do we standardize that? Now, what I'm finding interesting is with this informed certification, they really talk about at data quality at a very high level, like it needs to be cleaned and inconsistent and stuff like that. But they're actually not using data quality dimensions, which I find as a great benefit to be able to understand exactly what I'm checking, okay, and what my concepts are and what my ranges are and things like that. And so this is typically what happens is, oh, we can't have missing values, okay, but sometimes we know we can have missing values. So what range is acceptable? Duplicate records that we can outliers, invalid data ranges, incompatibility data types across sources. These are the things we know how to deal with. Okay. So the big question is, why is the data scientist doing it? And then you say, okay, well, maybe because they're getting it from a data lake. But then we know that we can be establishing a data lake house on top of the data lake to help them deal with this issue. So we can contribute a tremendous amount to the challenges that the data scientists are experiencing. And we've got the techniques. We've been doing it for long enough. We've created master data. We can create ways of them looking up for doing entity resolution. So they've got some of the data in the data lake. How do they do an entity resolution on the patient or the claimant or whoever it is? Okay. So feature engineering, this is the area that I'd like to, and I'm probably going to stop here because I think this is, for me, if I can do a great job on getting these features right, and we know that from making decisions, if people need to make decisions, they need to have good quality critical data elements that support that decision making. There is no difference between us and the machine. Yes, the machine can use predictive things and forecasting and things like that, but it still needs good quality data. So typically levels 1, 2, and 3, creation of the features. We can actually derive new values. And so dates are tricky in terms of working with it, but a better feature is date since policy inception. So how old, what is the age of the policy rather than what is the starting date of the policy? I'm hoping I'm showing you some examples of how we can prepare this data better for mathematical operations. Okay. So we can then analyze the grouping and the normalization of days since policy. So when do we get our first claim that's anomaly? Let's just think about that. We may have a problem, so we go and quickly go to the insurer, we insure something, and then the person dies 3 weeks later. Okay, that's a terrible example, but that's what happens. So the younger the policy, the possible potential of fraudulent claims are higher. Okay, feature transformation, normalize the data, standardize the data. And I remember talking to Paul about how do we standardize these big features and small features? How do we get them between 0 and 1 so we can analyze them better and understand the density and just look at them in a better way. Then feature selection. Okay, identify and retain only the most valuable features. So if you have 2 features that have a high level of correlation, you can drop one because you can be dependent on the other feature. If you have a feature that makes no sense or has no impact, you can drop it. It's not making any sense. Okay. So good feature engineering often makes a difference, and it probably makes a difference more than the algorithm. So am I using one class or isolation forest or whatever it is? If I give them good features, then I understand the relationships of the data. Normal data, people data governance, you can work on this as well. And here's just a flow on saying, okay, we want to limit the model to 20 predictive features. Okay, so pre-filtering, remove data features that have low variance. Okay, so if everyone is sitting around an average, well, let's say the average is 0.5 and the standard deviation is 0.001, well, it doesn't really matter. This guy has got no variance in it, so take it out. Missing values, high correlations, if there's very close to each other, well, get rid of one. You don't need both of them because they follow each other. Then we go into filtering techniques for classification or for amounts. And then we've got this process that they call recursive feature elimination, where it keeps going around and reducing the features, removing the features until we've got an appropriate set of features. Now, When we get those features, then what we've got to do is evaluate the performance of those models and then compare the model's performance with 5 features or the model's performance with all the features. Okay, how well is our prediction happening? And I think that's critical, is this constant validation and training. Evaluate the performance, accuracy, F1 score, RMSE and R squared. So those are important. And here's the high-level flow. Clean up on the data, high correlation, remove, low variance, remove. You get a set of clean features. We go into a top 40. Okay, these are our ones that we're working on now. Then go through feature elimination, trying to get down to the 20 features, and then evaluate it. How well is these 20 features doing? And then if the machine starts to deteriorate once it's in production, we may be missing a feature. We may need another feature. We've skipped a feature, or some of the features are not doing, and we need to keep on going round and round that loop. So I'm going to pause, and I'm going to stop at this point in time just to see if there are any questions, see if there's anything that you'd like to discuss. I don't want to go too much longer on this. Any questions?
Howard?
Yes, Paul.
How's it been? No, I was just thinking, I haven't got quite to that planning of resources, assets
Yes.
Yet, but just what came to mind when you were talking about that is there is a staffing mix concept or staff planning concept that's used where, depending on the type of ward, depending on the patient
Yes.
types, that what they call a skills mix of nurses
Yes.
that's required
Yes.
for a week or whatever the case, whatever period. That's variable. And I was just thinking about how the reinforced learning would be quite useful for that type of planning, because one of the use cases that's been asked to in the modeling to bring that data together somehow is linking what was the skills, or answering the question, what was the skills mix at a never event? A never event being we lost a bed, or we cut the wrong
Right,
foot off,
right.
or whatever some of those
Yeah, yeah.
nasty things that happen in hospitals.
Yeah.
But and obviously part of the you want to reduce those never events as much as you can, obviously. And so trying to understand what was the staffing mix and trying to understand what went wrong. And I just was thinking this reinforced learning could be useful as you gather that data of situations, to plan better
Right.
allocation of the nursing mix.
Right.
Yeah.
And Paul, I actually found this the other night, and I was going to send it to you. And this is part of the informs. And what they were asking here is to see if a chatbot can help them with their operational research. And,
Yes.
and it's exactly what you're talking about, this idea of having the appropriate skills mix. And the business process was trying to say, well, how many doctors and how many nurses should we have at a off-site clinic? And how do we get the people through as quickly as possible? So you can
Yes.
see here 4 clinic hours that were
Sorry,
done.
stop sharing if you don't. I don't know what
Oh,
happened.
sorry. Okay. Okay. So this is the one I was talking about, and a really nice discussion on informs about using ChatGPT or Claude or whatever it is to help describe the operational research technique that they should be using to decide on the appropriate skills mix. So they use something called job task analysis, which is what you're talking about. And then they look at deliver outpatient ophthalmology consults within 80%, less than with a 2-hour turnaround, despite.
Yes.
So that's the purpose that they need to do. And then they analyze the tasks and the resources and the workflows and the performance targets. And they go through using DMAC and SIPOC and situations like that. So
Yes.
I found
Sure.
the data collection to be the most important point, but more than the data collection, it was breaking down the tasks of what you're talking about. So what I realized from reading this is that I would need to be able to answer you properly, you need to do a really good breakdown of the job, task, action thing, right? So I can certainly suggest that, you start off with applying an operational research approach to this, with problem framing end to end, understand the purpose, understand what you're trying to achieve, and then looking at the right model to tackle this.
Brilliant. Thanks, Howard. Awesome.
Okay. So I'll put this link. I'm hoping that it's for everybody. It may just be for people that are registered. But it was amazing there, just to give you a high level thing that would.
Yes.
So the question was, is it a doctor bottleneck? Is it a nurse bottleneck? Can we use nurses to remove the doctors, in terms of, can they do some quick checks on the people before the doctor gets there, and where's the time being spent and things like that? So it's
Exactly that. Yeah.
It's
Sure.
complicated. No, I like this way of dealing with your site box and your value streams and things like that, to be able to frame the problem before you start trying to solve your problem,
Yes.
and
Yes.
recommend appropriate resource allocation. I'm hoping that makes sense.
No, brilliant. Thank you. I'll have to take a look at this.
Okay.
Yeah.
So when you get there, come and talk to me.
Okay.
I think this operational research is really important, in terms of what should we do. Remember those questions. What happened? Why did
What
it
happened?
happen?
Why did it happen? Yeah.
How long is this thing going to take if we send that consult out? And then what should we do? And I think you should be starting with something like this before you go too far.
Cool. Thanks. Thanks for that. Brilliant.
Okay. Thanks, man. William.
Yeah, I think one of the biggest challenges we have whenever we go into formulas and algorithms and all the rest of it is the question around variables and the variability of those variables. Because very often we want to kind of say, oh, well, this is pretty fine. This is pretty much a constant, so we'll just consider it this. And then, so if you think about your nurses, well, one particular patient might require a lot more time and effort because they're slightly deaf and all the rest of it. As opposed to, it's that variable nature of reality that sometimes we don't factor in. And I think if we just know where they are, it will help us to navigate around them, leaving some space for those variables to actually be brought in by human agents.
Yeah, and if we just look at this situation of them doing a whole lot of time or activity-based analysis, a nurse vision exam takes 30 minutes. This is your fixed dilation time and your time vary. So collecting all of the data in terms of what's happening and what are the time periods that there, that's the sort of data that you need to have before you can decide on the features and then the use of optimization.
Agreed, but I think equally important is you want to know what created outliers. What were the things that pushed it beyond the 30? What were the things that made it?
Yeah, but I think, William, what you need to be able to do is you first of all got to understand the features. You've got to then collect the data, and then you start profiling. Okay, but I need to make sure that the data I've collected has the set of appropriate features, and then look at the distribution by feature to be able to understand what we're dealing with, right?
That distribution by features where it'll come out. Okay, cool.
Yeah. And I was doing data quality today, and it really struck me how, in data quality, we spend probably 80% of our time on column-based data quality and maybe 20% of our time on record-based quality. Maybe when we do master data, we go into the golden record, but a lot of the times we all just column-based data quality. Now, what you're doing when you're getting into machine learning, you're talking about record-based learning. So what's the relationship between this feature, that feature, and this and the other feature? Okay, so there's a different level that we're operating. Does that make sense, William?
Yeah, and it does mean a level up in the way of people thinking.
Yeah.
One of the things I'm really loving about what AI is doing, and if we look back, when business intelligence first came in and various of the other things came in, it really created this change in the mindset. People got excited about a new way of thinking. And you know, our brains get bored eventually with the same stuff, and this is really refreshing.
Yeah, and it's what's fascinating for me, William, is the more I delve into the quality and the governance of AI, the more I see some of those options in data quality where I can help, you know, where I can improve the data that they have. That to me is really nice, you know, where I can see what more I can do for the data scientists not to fight with this content.
Yeah, as always, Howard, this is fantastic. Thank you.
Thank you. Great. Any other comments? Adam, you've been quiet. I'm sorry I terminated your earlier discussion, but you haven't said much.
I have. I'm sorry. I had a couple of calls I needed to take.
Oh,
there.
okay.
So
I can
I
always
just
detect when you've got some other calls when you're quiet.
because I'm quiet.
Yes, that's right.
So, yeah, I'm very anxious for Dale to finish his
Okay.
papers.
All right.
I'm anxious
Your
to
head
look
is
at that.
your head is in
And
that
I
department.
and I pinged William to send me a connection request as well.
Right. And Christy, you mentioned something that you were doing a similar thing. Anything on that? What is something that you
Oh, I did.
it was that feature engineering.
Yeah, it was something I did a couple of years ago. So I did a huge propensity model. And I think when we started, so, you know, there's always grandiose ideas when you start something like this, right? Because you want to see all of these different things and how they affect the question that you're answering, right? And so, of course, this is an advancement. We're looking at, you know, what's the propensity to give. And so I think we started out with like 200 and something features, right? And so that's a lot of features. But the nice thing is that when, like, I use AWS, right? And I love SageMaker because I am able to go in there and really, really, really get down to the record level, like you were talking about, record level data quality versus column level, so that you can see the different interactions between groups and so forth. So I think we ended up with less than 20 features at the end, right? But I was able to see the comparison of something with all the features versus something with just the 20 and the difference.
Yeah, that's such an important thing, and then certainly if we bring it back to retrain or if we add new features, we always need to be doing this comparison and making sure that you're not running into any challenges on that side.
But it's definitely about the data too, right? So that's the thing, like, you know, what I'm trying to achieve here is that I am the analyst, right? So I am the one that does the machine learning analysis and so forth. So I am the analysis data scientist. So I know what I need to do my job. And so that's great. If we were to have other people like me, I would know what they would need, because I think the data, making sure that it is of quality. But this also applies when we're using other things. If we're not doing a machine learning analysis, we're doing something like an LLM, the data that we put into that is extremely important, and looking at the data quality in that respect as well.
Correct. And I loved the discussion we had last week where we talk about being able to use something like a knowledge graph where we're integrating transactional data with content records and documents. And now the RAG is working off the knowledge graph instead of having to bring them all separately and understanding those relationships. That's also great. Now, the one story I had was working with the econometricians in the central bank and their analysis of GDP, and they had these 14 core features, and the visualizations that they had to compare the different features. When I looked at this thing, I could hardly understand what those visualizations were saying until someone, an econometrician, sat me down and said, "Can you see the comparison between this one and this one?" It's like, wow. If I was trying to explain it on my own, I'd get lost. But that was all about doing nowcasting on the GDP figures in terms of saying, well, if this was the GDP, what's our response? What response do we have as a monetary policy? Excellent. Any other questions?
Yeah, I just want
I'm
you to
hoping-
carry on working on that cloning job that you've got to do, right?
I'm waiting for you, William.
I've got to invent the cloning machine to clone you, right? All right, no, good.
Fantastic.
Thanks, Howard.
Thanks, everybody. I just wanted to have a quick check there is from a governance point of view. Paul, I'd love to see your feedback. Is this too simple, the machine learning AI that I'm presenting, or is it too complex, or do I need to simplify it some more? I wasn't sure that I'm at the right level to help people recognize and understand what it is they're dealing with. Yes, Naroshni.
Roshni? We can't
Can you
hear
hear
you.
me now?
Paul?
Yes.
Yes, I can hear you now. Yes.
Howard, can you hear me? Okay.
Yes, I can.
So what I'm looking for is ethical governance, because remember, we quite far back in terms of we have sections that are doing AI, but there wasn't a
Right.
thought about the AI, the ethical governance, and putting in the governance protocols for machine learning. I would really like some material, if any of you can share with me, on ethical governance and machine learning models for putting that governance structure in, because we're now getting everybody asking about implementing a large language model and using AI. And it seems like a real buzz, but we're also trying to get them to understand, since we're starting the journey of governance within our business unit, we'd like to implement certain things and certain governance protocols so that when it does read, like data quality is a real issue, because business is not happy when we say we need accountability, we need ownership, and we need proper data stewards. You're getting pushback because they never understood the importance of it until we start having these chats.
Right. And
So if you've got anything that you could share with me.
yeah, I do, and I was trying to build the understanding of the machine learning and the AI before we start talking about how do we assess these issues like fairness, transparency, accountability. How do we bring them in? So, like transparency, interpretable models. So how do I remember? I don't know if you. I think you may have came a bit late, but the one thing that I found really the contrast is with software and with some of the BI and derivatives, all the rules are defined by the SMEs. We go to the SMEs and they tell us what the rule is. When we go to machine learning, it discovers the rules. The rules are no longer documented. Okay. So we then need, when it makes a decision, we need some way of it explaining the decision to us so we understand why it is. And that would help us to say, well, we start picking up patterns. Well, you keep on making this decision and you keep on explaining your decision based on race or based on location or based on this. And then we can go back to the bias and the fairness audits. Are we giving too many anomalous claims for this group of people? Are they having more anomalous claims than this group of people, this location, this age? So being ageist or whatever it is. So you've got to understand how the models work, how to interpret and explain the results, and then you can start detecting biases on that. That's the way I've worked through a lot of this stuff.
And Howard, I'd like to put in, because I just had a webinar that focused on this, and it was actually a third-party tool where you were able to put in every single rule in you'd make categorizations of rules, and then you would put the individual rules into those categorizations to prevent the model from being able to do certain things. And it was very surprising. It was the first tool of that type that I have seen that actually made governance user
But
friendly.
I think what's I think what's so I think there's a step before I can tell it what the rule is. I need to discover those rules. Okay, because part of my challenge, if we look at a simplistic anomalous claim, the business people have made a very simplistic thing of, oh, if it's this amount of age or this thing, then it's a fraudulent claim. But a lot of those rules come from biases in the past. So we almost have to, in some cases, I'm not saying in all cases, but in some cases, we have to start from a unsupervised learning, see what the patterns are there, then try to see if we can interpret what those rules are, then start to use that reward system as well in terms of reinforced learning. So I think we have a journey.
I
If
would
you were to
I would
ask me,
agree
put all the
with
rules
that.
down now, I'm not sure.
I would agree with that, but I would catch that aspect of the requirement before it got implemented from the stakeholder and explain to them why that is not an appropriate rule to put in.
Oh, yeah. But look, I think what we can be doing, Adam, is when we find our data and when we profile our data and when we look at the features that would use to predict it in terms of the training, that's when we're going to be going back to them to say, well, you said that, but that's not the way it's looking, or this is the problem with that. You've got a bias in this grouping or this. If we take a feature and we bin it, okay, and we break it up into little pieces, okay, where is most of the anomalies coming in, and is that bin correct?
Yeah.
I agree. There are going to be those circumstances where it may be a seemingly innocuous rule,
Right.
but it has unintended
100%.
consequences.
100%.
Yes.
And that's where we have to be really working with that data and understanding it and almost letting the data speak to us before we speak to the data.
Mhm. And that's why I put in the chat, you have to have that transparency of the reasoning. It has to
Yes.
explain how it got to those decisions.
That's been the most exciting learning that I've got is using algorithms to explain the decisions, because sometimes when I see these anomalous claims, it's like, how did you get there? Now, please explain it to me. And then getting some support on doing that, that's quite revelation. It's like, wow.
Exactly. It's the rule of unintended consequences.
Yeah, correct.
And I
correct,
see that,
correct.
I mean, that applies in so many areas,
Right.
especially whether it's banking,
Right.
manufacturing, etc.
Yeah, because we've been making decisions based on gut feeling for so long now that they become entrenched. So Naroshni
People see what's in front of their face.
Yeah.
They don't see what might happen down the road.
Right. Naroshni, is this helpful in terms of what you're looking for?
Yes. Also,
Okay.
in terms of putting in a governance structure, I'm looking for, when you're setting up your framework, right? Where can I get information on setting up the machine learning model and ethical governance? Because remember, when new things are happening, you want to put these in the framework so that you don't have people going back and just doing things willy-nilly because it's the buzzword AI. So
Naroshni,
I want to know from that aspect.
Naroshni, what I tried to do there in one of the presentations was actually show you the development life cycle in terms of the monitoring, the choosing of the data, the features. That's the process that you need to entrench, not so much the models, but the implementation framework that you're using. Okay, that's the thing that you need to understand. Okay, now
So I just something very important from what you, So what I wanted to say that I'm seeing that I didn't think of before is using the self-discovery to see what the data is saying so that you can pick up where there's issues and anomalies and problems. And then you can go and do corrective measures on them so that when you totally implement a solution, you can, you're getting better insights over the journey.
Yeah.
Perfect. I got it.
Fantastic.
I probably
Thank
will have
you.
to ask Veronica to send you the recording, but thank you so much.
Yeah. You ask Debbie. Debbie manages the recording, and we typically put it on LinkedIn, and then when we finished editing, then people do it there so we can control how it goes. Yeah.
Yes, but I can
Okay.
definitely help.
Thanks. Debbie, you had your hand up.
Yes, I just wanted to go back to the question that you asked before. I know you were asking if I might not word it correctly, but if you use the right language and the right level.
Yeah.
And I'm sorry if I'm picking on this person, but I think Pranav would be an incredible person to answer that question. As he is starting in the data governance field, and he joined our training last week. So Pranav, if I'm not putting you on the spot, I think you would be a great person to help with that feedback for Howard.
Hi, can you hear me?
Yes.
Yes.
The delivery of this webinar was really good. It gave me some good insights. However, I did lack quite a bit of knowledge prior to this, so there were times where I was lost. But overall, if I go and watch the previous webinars that Debbie sent the links to, I'm sure I'd get up to speed. But yeah, it's also helped me open up my perspective because I'm implementing tools like Microsoft Purview, and with regards to data discovery and stewardship and whatnot, I could relate to certain things. So it was good when you brought that up because it helped me connect the dots quite a bit.
Okay. Thank you.
Thank you, Howard.
And Pranav, was the terminology that you were lacking related to data science and the machine learning, or was it related to data governance? Which area?
It was more to the AI and machine learning aspect. That's an area that I'm actually looking into getting into and learning more about. So it's the conversation today helped me open up my perspective about it in general. And I've taken some notes and stuff that I'm just gonna go over and in my spare time, whatever it is. Yeah.
Okay. All right. I will. The training that I'm putting together for the AI governance is really also trying to help people that are moving into it just get the grounding so they don't feel at sea, so they can ask the right questions and ask to see what the people are doing and not feel like they're getting in the way or getting stuck. Thank you.
Thank you, Howard.
All right. Thank you. Yes, William.
Yes, so Howard, I think that age-old statements, it takes a village to raise a child, is just as important in a company. It takes a company to raise an AI. It can't be done in isolation because what might look like a good reason from one person's perspective that the AI is giving as to why it's done something may be a real big problem downstream, upstream, or in some other area. So I think we need to just, in that governance space, be able to bring something through and have that conversation around this is what the reason was. How do the governance council feel in terms of, is this reason something that's going to hurt somewhere else, someone upstream?
Yeah. And William, I've just put a paper together in terms of talking about the unification or the unifying of the different governance silos. And it was interesting. We had a feedback from Christy last week in terms of, please also remember, this is not just data governance. This is records management. This is data privacy. This is cybersecurity. This is AI governance. So we almost all have to work together to ensure that we growing the AI model in the way that it needs to be grown, because we're looking for all sorts of angles of natural language on the content. Is this the right record? Do we have the right quality in this record? Things like that help these models and help us grow the AI system on automating this scenario. That was the one thing that I've done. And then I've also been looking at what they call socio-technical governance, which means it's about the people, the goals, the metric, and as how do we grow those people to reach and to deal with the technical complexity of these systems that are being put onto us. We have to be aware of that. It's not just about, let's do a good data governance job, but what about the people that are being affected by this job? How do we manage that?
Yep, it's a complex thing, but that's what makes it fun, right?
Yeah. So if you're interested, William, I have some presentations on socio-technical governance in terms of working with people and working with content and working with data to deliver the right answer.
Yeah,
and I think, yeah. So, Paul, I know I did ask you a question a long time ago. Your mic's off, and I wasn't sure.
No, thanks, Howard. I was just listening intently about the reinforced learning, the unsupervised learning, revealing the ethics that are embedded in the organization through the data and how the data is being used and behaving. That's fascinating.
Fantastic.
So thanks for that. And also just the presentation slides to answer that question. I also probably need to just run through it again, but I don't think it's too simple or too much. So it's good. Very good.
Great. And then we just had something from.
I really
just had a.
Because you know what the reality is, right? How often do we say something and then realize, oh, is that what I was thinking?
Yeah.
That's the same problem.
Right. And so if anybody's interested, this is a paper from Dale in terms of ethical AI integration, Naroshni. This may help you as well. It's in the link, so if you're interested. Now, what you can also do is look at the EU AI Act, and it also deals with trying to enforce responsible AI and to get it up and running. So these frameworks that are coming out are fantastic, and that will really help us. Great. Guys, thank you very much. Have a wonderful night, day, weekend, and we'll see you again next week sometime.
Another great session as always, Howard.
Yeah.
Thank you very much.
Thank you so much. See you on Tuesday.
Thank you, Howard.
And this may be one of our biggest ones.
Yeah.
I think we may have had more attendees today than I can recall anyway.
Yeah, fantastic. And Dale, we'd love to have you talk and present at some stage. We'd really appreciate your input that you have.
Yes,
I would
indeed.
love to. And Howard, I'll reach out to you. I have a couple of products I'm working on that might be of interest to you that we might collaborate on if you're interested.
That would be great. I'd love that. Thank you very much.
All right, talk to you later.
Cheers.
Thank
Cheers,
you.
everybody.
Bye.
Take care,
Thank
all.
you. Cheers, Adam. Have a good one. So, Adam, we should talk about if you want to get involved in some of the training. That's a way of presenting some of the stuff and creating a training in your side of the world. So.